Hello friends, welcome back to our channel The Quantum Quest. In this video we are going to discuss about scalar triple product. So let's dive in. Definition. The scalar triple product involves three vectors. If A, B and C are vectors, the scalar triple product is written as A dot B cross C, which is equal to box ABC. Now scalar triple product is also known as box product. Now this expression means first take the cross product of vectors B and C, which results in a vector, then dot it with vector A. This gives us a scalar. Now this expression has a determinant form, so we can see what it is. In component form, we can write vectors A, B and C as Ax, vector A is equal to Ax, Ay, Az, vector B is equal to Bx, By, Bz, vector C is equal to Cx, Cy, Cz. Now A dot B cross C can be expanded in the form Ax times Bycz minus Bzcy plus Aybzcx minus Bxcz plus AZBxcy minus Bycx. Now when you look at this expression, see it is in the form of a determinant, expanded form of determinant. So this can be written as A dot B cross C equals determinant Ax, Ay, Az, Bx, By, Bz, Cx, Cy, Cz. See here there is Ax, then By, Cz, Bz, Cy. Here there is Ay, Bz, Cx and Bx, Cz. Here there is Az, Bx, Cy and By, Cx. This is how the determinant came. Geometric interpretation. The scalar triple product gives the volume of a parallel pipe formed by the vectors A, B and C. This is the image of the parallel pipe. It contains vectors A, B and C. Now, how to calculate the volume of an object? The volume of an object is always equal to its base area times height. Now, base area is given by the cross product of vectors B and C. First, when you take the cross product of vectors B and C, you will get a vector which is perpendicular to the plane containing B and C. See, this is the vector. The magnitude of this vector will give you the area of this parallelogram. Now we have to find height. Height of this vector is the projection of vector A onto vector B cross C. So when you calculate all this, you will get the volume of this parallel pipe. That is the box product of A, B and C. Now scalar product has the cyclic property A dot B cross C equals B dot C cross A equals C dot A cross B, which is equal to box ABC equals box BCA equals box CAB. Let's do some exercise questions. Our first question is find the volume of the parallelopipe with adjacent sides. OA vector is equal to 3I cap minus j, OB vector is equal to j plus 2k and OC vector is equal to I plus 5j plus 4k. Now we have to find the scalar triple product of OA we have to find OA dot OB cross OC. This can be written in the determinant form. First we have to write the components of OA vector. So they are 3, minus 1 and 0. Next we have to write the components of OB vector 0, 1 and 2. Next we have to write the components of OC vector 1, 5 and 4. So when you expand this, you will get 3 times 1 into 4 is 4 minus 10 minus of 1 times 0 into 4 is 0 minus 2 times, sorry, plus 0. 0 into 4 is 0 minus 2. So this term is 0. So this one will become 3 times. So this is 3 times 4 minus 10 is minus 6 plus minus 2. This is equal to minus 18 minus 2, which is equal to minus 20. Now the volume of this parallelopipe is 20. So the answer is 20. We have to only take the magnitude of this value. So answer is 20. Okay, our second question is, find the volume of the tetrahedron whose vertices are the points A, 2, minus 1, minus 3, B, 4, 1, 3, C, 3, 2, minus 1, and D, 1, 4, 2. The formula is 1 by 6 times AB vector dot AC vector cross AD vector. So we have to find AB vector, AC vector, and AD vector. Now AB vector is 4 minus 2, 2i, 1 minus 1, which is 2j, 3 minus 3 plus 6k, and AC vector is 3 minus 2i, 2 minus 1, that is 3j, and minus 1 minus 3, which is minus 1 plus 3, which is 2, plus 2k. Now AD vector. AD vector is 1 minus 2 is minus 1 minus I, plus 4 minus 1 is 5, 2 minus 3 is plus 5k. So this is our AB vector, AC vector, and AD vector. Now put these values in our formula. This is the volume of tetrahedron. Volume of tetrahedron. Then when you take the determinant, first we have to take this value, the box product. So it can be written in the determinant form, times this 1 by 6 will give you the answer. So the answer is 1 by 6 times, first we have to write the components of vector AB, 2, 2, 6. And next we have to write the components of vector AC, 1, 3, 2. And next we have to write the components of vector AD, minus 1, 5, 5. This is equal to 1 by 6 times 2 into 3 into 5 is 15, minus 5 into 2 is 10, minus 2, 1 into 5 is 5, minus 2, plus 6 into 1 into 5 is 5, minus 3. Now this is equal to 1 by 6 times 2 into 15 minus 10 is 5 minus 2, 5 plus 2 is 7 plus 6, 5 plus 3 is 8. Now which is equal to 1 by 6 times 10 minus 14 plus 48. This is equal to 44 by 6, which is equal to 7 1 by 3. This is the answer. Our third question is, choose y in order that the vectors a vector is equal to 7i plus yj plus k, b vector is equal to 3i plus 2j plus k, c vector is equal to 5i plus 3j plus k are linearly dependent. If three vectors are linearly dependent, then their box product, box ABC, equals 0. Box A, B, C equals 0. So first we have to find the box ABC, which is determinant box ABC, A dot B cross C equals determinant 7 y 1 3 2 1 5 3 1. This one equals 0. So we have to find this determinant. We have to expand this determinant. Now 7 times 2 into 1 is 2 minus 3 into 1 is 3 minus y times 3 into 1 is 3 minus 5 into 1 is 5 plus 1 3 into 3 is 9 minus 10. Okay, this is the LHS. Now when you expand the LHS, you will get 7, 2 minus 3 is minus 1 minus y, 3 minus 5 is minus 2 plus 9 minus 10 is minus 1, which is equal to minus 7 plus 2y minus 1, which is equal to 2y minus 8. Now 2y minus 8 is equal to 0. So y is equal to 8 by 2, which is 4. This is the answer. So if y is equal to 4, then these three vectors are linearly dependent. That is, their box product equals 0. Our fourth question is, prove that box product of vector A plus vector B plus vector C, and vector C plus vector A equals 2 times box product of vector A, B and C. So first we will start from the LHS. Box product of first we will start from LHS. So box product of vector A plus vector B plus vector C plus vector A can be written as vector A plus vector B dotted with vector B plus vector C cross vector C plus vector A. Now we have to use the distributive property. Vector A plus vector B dotted with, when you expand this, we will get vector B cross vector C plus vector B cross vector A plus vector C cross vector C plus vector C cross vector A. Now this term is equal to 0. Any vector taken cross product with that vector itself, that gives 0. So this term is 0. So vector A plus vector B times vector B cross vector C plus vector B cross vector A plus vector C cross vector A. Now we have to expand this, so we will get vector A plus vector B dotted with vector B cross vector C plus vector A plus vector B dotted with vector B cross vector A plus vector A plus vector B dotted with vector C cross vector A. Now we have to expand each term, so we will get vector A dot vector B cross C plus vector B dot vector B cross C plus vector A dot vector B cross A plus vector B dot vector B cross A plus vector A dot C cross A plus vector B dot C cross A. Now this term is 0 because when B cross C is taken, it will give a vector which is perpendicular to the plane containing B and C, and when that vector is dotted with vector B, it will give you 0 because the angle between these two vectors will be 90 degree. So cos 90 is 0. We have learned about the scalar product in our last video. So similarly, this is also vector A dot B cross A is also 0, and vector B dot vector B cross A is also 0, and vector A dot vector C cross A is also 0. So the remaining terms are vector A dot vector B cross C plus vector B dot vector C cross A. Now this is equal to box ABC plus this is equal to box BCA. Now these two are the same itself because I already told you that the box product has this cyclic property. So these two are same. So this can be written as 2 times box A, B, C, which is equal to our RHS. Hence, we have proved our relation. In the next video, we will be solving some more problems about scalar triple product. So that's all for today. Thank you.